All right. Let's see what time we got. It's
Take
10:06.
the red pins from group 4.
Okay, we have less than 40 minutes, so we really got to get going so you can get to work, okay? So just to review, when a number or variable has an exponent, we can say that it's raised to the power of that exponent, okay? You guys should already know this, but I want it in writing just so we're all on the same page. Okay? For example, if we have 2 to the power of 4, we can say that we have 2 raised to the power of 4. Right? That's how we would speak that term out. 2 to the 4th. Or we could say 2 raised to the power of 4. I don't have a first period. I have first period prep.
So this is the first. How many times do you have to write it?
3 times a day. But I already have the ones that I wrote over summer, so.
Why? Why do you write it again?
Because if I just show you the information, you'll just look at it and zone out. If I'm writing it with you, then we're all on the same page at the same time. At least that's what I've seen has been helpful. Last year I tried PowerPoints and it didn't work. And then I started writing the notes.
What about not like the whole thing? What if like you just show pieces of the page at a time?
That's a good idea too. But I kind of like writing it out. It allows me to get a feel for how you guys are writing. If I'm going too fast or too slow. But if something changes, we'll change it. But I like how we're doing it so far. So the power rule is this. If a base raised to a power is then raised to another power, keep the base the same. Sounds familiar, right? And then what we're going to do is we're going to multiply the exponents. How we doing? We still writing? Thumbs up if you're ready to move on. Otherwise, just keep writing. Okay, I'll give you another minute. All right, so let's see what this means. Luckily, it's pretty straightforward. So let's do example A. Let's go inside the parentheses 2 to the third. Outside the parentheses, let's give an exponent of 4. So if you look at your Unit 2 little half sheet that we glued in to the front of our notebooks, I believe this lesson says power 2 a power rule. Technically that's what it's called, but I just shortened it to just power rule, just to make it easier to write and remember. But you may also hear it called power 2 a power rule. So what we're going to do with this is kind of like what we've already been doing. With product rule, we added our exponents. With quotient rule, we subtracted our exponents. Now with the power rule, we're just going to multiply our exponents. So we'll keep our base the same. That's a 2. Our exponents are 3 and 4. And we are going to multiply those together. Giving us an answer of 2 to the power of what? Anyone got that one? 12. 2 to the power of 12. 3 times 4 gives us 12. Example B, inside the parentheses, let's do x squared. And outside, let's do negative 2. So, x to the second raised to the power of negative 2. We could also say this is x squared to the power of negative 2. We're going to keep our base the same, and we're going to multiply our exponents. Now the reason why I'm putting parentheses around the negative 2 here is because when we're multiplying, we don't want to confuse those signs. With addition and subtraction, as we know, 2 minus signs next to each other make a plus and a minus next to each other make a minus, but a multiplication and a negative sign don't do anything. You're just multiplying a negative. So I recommend putting parentheses around your negative numbers when you're multiplying, just so everything is a lot clearer, right? Especially if it's all in the same color. If you're just using pencil, it's going to look a lot more confusing without these parentheses. What's positive 2 times negative 2? Noah?
Negative 4.
Negative 4. Awesome. Great job. Negative 4. Is that our final answer? Can we do something else to that to make it prettier?
Oh, yeah.
Maybe not a negative exponent? What would our final answer be if we use what we learned in 2.1a? We're going to turn into a fraction and flip it, right? So x to the positive 4 is on the bottom. And what's on the top?
1.
Just 1, exactly. So from this point forward, your answers should not contain negative exponents at all. First couple days, I allowed it, but now we gotta use what we learned on Monday, flip that fraction, and have positive exponents in our answers. Let's do something like this. Let's do 4 squared to the 1/2 power. Ooh.
Is that question going to be on the worksheet?
The 1/2 power one?
Oh.
No, there's no fractions. Oh, that's not even today's worksheet. No, there's no fractions. But let's do this one anyway, because I haven't taken a look at the IXL yet. So 4 squared to the 1/2 power. Have we seen a fractional exponent before?
No.
I don't think so, no. Okay, so this is our first look. But it's okay because all we're doing here is multiplying, right? Keep our base the same. 2 times 1/2. Okay, so the fraction looks scary, but we didn't do anything different. We did the exact same thing. What's 2 times 1/2 equal to? 1, right? Half of 2 would be 1. 4 to the first power, which is equal to just 4. Let's just write it as 4. I'll give you guys a second to write that down and stare at it. Oh, we got it. All right. So just like with our previous lessons this week, let's find out, why does this work? Thank you, Noah. That's right. Why does this work? It's a nice shortcut, right? It's pretty easy to use. But how are we even able to use it? Let's find out. We're going to do what we have been doing, and that's expanding example A. Which was 2 to the third, all to the fourth. 2 cubed to the fourth. So let's expand this out. We've got 2 to the third power. We can't expand that out, but let's just leave that for now. Let's expand out this 4 exponent here. Because when this 4 is on the outside of these parentheses, it's telling us that we have how many 2 to the thirds? 4 of them, right? So let's write out 2 to the third times 2 to the third times 2 to the third times 2 to the third. Didn't change anything about our problem. We just expanded it out. Now we can expand out 2 to the third. Each of these little 2 to the thirds.
Thanks for lockdown.
Was it an Amber Alert?
Yeah.
Jesus.
Oh, the test.
Was it a test?
That's scary.
Okay, jeez. All right. Everything's fine. Everything's fine. Scared me a little bit too, but we're fine.
What test?
All right. Let's all take a deep breath in and out. Okay. That was a little weird, but it's all right. Let's jump back into it. This is the last thing we're going to do, so let's just finish strong. So if we expand each of these 2 to the thirds out, we're going to get 2 times 2 times 2, and then we got 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. I could have picked an easier example, but that's all right. So this is our fully expanded out expression, right? We had this super condensed question to start, but this is just saying this exact thing. 2 times 2 times 2 a bunch of times. How many 2's do we have in total here?
12.
We have 12 of them. Interesting. We have 12 2's total. Therefore, our answer is going to be 2 to the 12th power. Is that the answer we got in our original example A?
Yes.
It sure is.
So is that just a way to make it harder?
What, this?
Yeah.
That's a good question. So yes, this is a lot more complicated. I don't expect you to do this. I don't really want anyone to do all this. This is just to show you kind of the back end of how this shortcut works. The lesson is on the shortcut, right? All of this, just the multiplying. That's the lesson. That's what I want to see. But this is just context as to why we're able to do that. Yeah. And then I had another example, but it's too difficult. Let's not talk about it. All right.
We only got like 15 more minutes.
We only have 15 more minutes? Looks like we got about 20.